Hello everyone again, and thank you for joining. I'm Felix Sieker from Bertelsmann Stiftung, and I will talk today about two things. Like one is the growing concentration of power in AI, and secondly about some alternatives to dominating AI models. And so we first, in this presentation, will look at some of the existing dependencies at different layers of the AI stack, and then I will introduce the concept of public AI, under which like many alternatives to the existing models are currently subsumed. And finally, I will show some examples of public AI interventions. So it's quite easy to be pessimistic these days on the entire development on AI, so I hope I can show some examples that are some positive developments that need to be mentioned. But first, to start, over the last 3 years, there was a staggering rise of generative AI, and which is the dominating technology at the moment, but currently it is controlled by a handful of firms in the US and China. And while I was researching some graphs for this presentation, I found this one quite interesting. It's by Epoch AI, and here it's they just mapped large-scale models by countries. And large-scale models here are defined as models with 100 to 500 billion parameters, depending on how efficiently they are trained, so quite big ones. But if you look at the countries, you see it is almost entirely controlled by US and China right now with ChatGPT, Gemini, Llama, and DeepSeek. Europe, for example, is not really playing a role at the moment. And, well, not all AI, but especially in generative AI, you see a really strong concentration of power. And to better understand the existing concentration of power, it's quite helpful to think of AI as a layered stack. So at the bottom you have compute, which consists of chips like GPUs from NVIDIA, which are most prominent, but also like TPUs, and Amazon also has some chips, and also data centers. And on top of that you have data and model, and these are kind of the core infrastructure, and applications are built on top of that. What is not shown here is software. Software is kind of a layer that is cross-cutting the entire stack, as it's necessary, for example, to use GPUs. And maybe some of you know that NVIDIA has quite a prominent computing platform, which is called CUDA, which is also probably the reason why the company is so successful. But software is also needed at other layers of the stack, for example, if you want to train models. So a defining feature of today's AI landscape is the unequal distribution of resources and financial returns, which exhibits some characteristics of a natural monopoly. I mentioned it before already, but that the concentration of power is particularly pronounced at the compute layer, because that's also the most capital-intensive layer. And here, NVIDIA is dominating, but also 3 major cloud providers, Amazon, Microsoft, and Google, are quite strong because they fund many of the existing data centers at the moment. So why is this problematic? It's problematic because cutting-edge AI models currently remain in the hand of a select few, with sometimes more limited orientation toward the public interest and also accountability and democratic oversight. So when such power is centralized, it obviously raises the political question, who gets to decide how AI is developed and shapes these systems. And I think a really good example of the problematic concentration of, or the consequences of the concentration of power was quite recently with xAI's chatbot Grok, which a couple of weeks ago was hallucinating about a white genocide in South Africa, which was a deliberate choice by the company's founders to train the model so that it would prompt that way. And yeah, we definitely, I would say, need more choice. And it's also fundamental that AI development is happening in the open, because currently it's mostly done within closed frontier labs. So that's why we also need more open models and open source models. So in order to think about alternatives, it's, I think, quite important to understand these existing concentrations of powers, also to formulate a realistic strategy to develop alternatives. So against this background, there's an increasing push for alternatives to the models of the same dominating companies. And that is often subsumed under the term public AI, which is still quite vaguely defined. It's not a clear definition, but can be understood as kind of a normative, bit more normative vision of AI. And there's some features or some characteristics proponents of public AI agree on. One is that public AI ensures that that the public has both visibility and influence over AI development, that data, software, and models are accessible on equitable terms, and public AI initiatives have a strong public interest orientation and public accountability. So in sum, public AI can offer a countervision to the status quo of consolidated power. And we've seen that in the last month, there was a bit of a growing momentum behind the idea of public AI. There was a report by a public AI network, and they currently try to build a foundation model, which is quite an interesting approach. We've also been involved with them a bit. And Mozilla is working quite a lot on the topic now. They have this report out, and also in their new strategy, try to engage more in the topic. And also we, 2 weeks ago, published a white paper on public AI. And the rationale behind our work was that we wanted to translate the debate into more actionable policy steps and develop a public AI strategy. So this is our strategy. So for us, public AI has a lot of overlap with open source AI, and we see open source AI as kind of a key pillar of any meaningful public AI strategy. So at the core of our proposed strategy is the objective that any meaningful public AI strategy should ensure that there's always a fully open source model with capabilities as close as possible to frontier models. So of course they won't match them, but there should be much more public effort also by the state to ensure that we always have a fully open source model, or at least an open weights model, but open source would be more desirable. And the reason is that fully open source models allow more transparency and also experimentation, adaptation, and democratic oversight. And this is what we call the public provision of a capstone model, which can be achieved by providing compute. So here's public compute for research institutions, but also public compute for particularly dedicated for open source AI development. I will say something about that a bit later. On the data layer, public data commons is nothing new, but it's still quite important. More data sets at such public goods. And we also discussed something that's not yet in the paper, but we currently work with another institute on that in a policy brief, that maybe we need some new licensing models for training data for AI, for example, because high quality data is still a big bottleneck in AI development. And if you look at Europe, for example, we have quite a lot of high quality data, which is either not accessible or it's scraped by hyperscalers. And so we think there could be a need to find a licensing model to regulate the access to that kind of data, maybe giving some projects that have a stronger public interest orientation better access to this data, because at the moment it's not happening and it's actually quite a mess in the EU. Yes, and then there are some additional measures we pronounced AI talent capabilities, because most AI talent is at the moment in the US and China, which is a big problem also to develop some models here. And the strategy is kind of an ideal scenario how public AI can be developed. But there are, however, already a few examples of infrastructure components or AI models that have some commonality to public AI. And for that reason, we also developed a to call it a gradient of publicness of AI systems, which is kind of a conceptual tool that should help policymakers to assess AI interventions that help to achieve public AI. And this framework maps AI interventions on the continuum from fully private to fully public, because this is how it's actually happening at the moment. You don't have normally fully public interventions, but it's always a mix between that. And we had this mapping based on 3 characteristics of AI. One is public attributes, which is something like accessibility, openness, interoperability. The second is public functions, whether these interventions enable some socio-economic goals. And finally, modes of control, which is public ownership and democratic governance. And we identified 6 different levels of AI interventions. And I want to show you these levels and also some of the examples we also mentioned in our paper, to show that there is already something going on and it's not something what we can build on. So in our framework, we distinguished between this 6 levels. The first one is commercial provision of AI components with public attributes. That refers to specific components to develop AI models, such as software libraries or, mostly software libraries that are necessary to train a model. And these components are typically publicly accessible, so have like high public attributes, but low to moderate public control and low to moderate public function. And one example here is PyTorch. PyTorch is a very important deep learning framework that was initially developed by Meta, but later open source and is currently governed by the Linux Foundation. And Meta and others have built an ecosystem of complementary research and innovation around it, with Meta, however, like taking the lead role here. The second is commercial AI infrastructure with public attributes and functions. That refers to privately controlled infrastructure that ensures some level of public access and has a public interest orientation. So we have here high public attributes, moderate public function, low public control. And one example is Hugging Face, which probably most of you know, which is it's a company that develops computation tools for building machine learning applications, but it also has a data sharing and model sharing platform, which is actually quite important. It's kind of the backbone at the moment for the open source AI ecosystem. Maybe some of you have already downloaded some models there. Third one is public computing infrastructure. That is something like supercomputers and data centers, which are currently funded through public-private partnerships. And these infrastructures have mostly like kind of unclear public attributes unless there are some specific conditions on how access to compute is regulated. They have low to moderate public functions and moderate to high public control. And the prime example is here the EU AI Factories initiative, which is financed through a mix of public and private funding. Their purpose is to support startups and research institutions, but also generative AI development is one of their goals. Level 4 is public provision of AI components, which is like individual components such as data sets, benchmarks, or evaluation tools, which are developed with public funding. They have high public attributes, moderate to high public function, high public control. And the example we mentioned there is like the Common Voice initiative by Mozilla, which is a platform for sharing voice data for AI training. So everybody can share their voice data, so AI models can be trained with that. And it's often cited as one of a best practice for open data sharing. 5, we have full stack public AI infrastructure built with commercial compute. That means here we have infrastructures that is high public attributes, high public functions, but depends on commercial compute and thus has lower public control. And the example we have here is Olmo, which is an example it's kind of a family of open models by the Allen Institute for AI. And it's quite an interesting example because it's a fully open source model. They also have open source the training data, which can be accessed. And what's so interesting about it is that it's quite good and performs quite well in comparison to other models such as ChatGPT-4. So they have quite a small team. So of course, it's a foundation, still in comparison to other foundations, they're quite big, but in comparison to Frontier Labs, they're quite small, and what they achieved there is quite remarkable. So we can have, in theory, fully open source models that have good capabilities and that can be worked on. And I think that can give us, well, not necessarily hope, but it's something we can work on. And finally, the last level is a full stack public AI infrastructure. It's similar to level 5, but here we have public compute. Because Olmo was mostly trained with private compute, so compute provided by one of the hyperscalers, I think it was Google. And here we have Alia as an example. Alia is a large language model developed by the Barcelona Supercomputing Center, which is a research institution in Spain. And it's also quite interesting because it sets quite high standard on transparency and openness, and also has a strong public function because it's a large language model that is trained on a couple of Spanish languages, not only Spanish, but also Catalan, and thus kind of fills the research, kind of a gap that still exists here. So just to finally conclude, first I think what you can take out of this presentation is like AI is increasingly a critical infrastructure, but it's dominated by a few companies. Public AI can offer a counter model. And I think it's really important to think like most AI interventions exist on a public-private spectrum. It's never like fully public or fully private, but we definitely need more public investment to shift the balance a bit more in favor of public AI.